most of you don't know me. I am QMX. My name is Douglas, but no one knows me by Douglas. I am the Gene.js creator, the open source JavaScript implementation. We will have a talk, next talk about it. I am a jRuby committer. This is the new jRuby logo. Most of people don't know it. It's a J-bird. OK, sketchy. And I really like open source. Probably, as you all are here, know how to value why open source is so important for us. It's running on our DNA as a company and probably as people, too. I want to talk a little bit about Ruby. Just for a sanity check, who here already worked with Ruby? Is there any hater here that hates Ruby? Oh, there's one. Well, the fact that we love Ruby, might you like it or not. But the main question, why not Java? Usually, when people start talking about Ruby, they are much more worried about, oh, that's because Ruby is highly productive or has the new shiny toys that guys are using on the market. But there's really tons of important things that we can learn from this language. The main fact is that, OK, let's make a convention. We love the JVM. The JVM is the most important part that we can bother about. And Ruby is no different. We only will enjoy the power of the language with some decent performance using it on the JVM. The JVM is a stack-based virtual machine, as you can see here. Anyone never heard about this? Everyone is fine, for sure. Stack-based machine, just for a sanity check, when I want to do these kinds of operation in a stack-based virtual machine, I usually will first convert this to something like that resembles a tree, and then I will start looking like Lisp. Not really. I will start to push all these arguments on my stack. So I want to make 1 plus 2. I push 1, I have 1. I push 2. Then I have 2 arguments on the stack. And then I make an operation and get the result on the top of the stack. It's not that complicated. The Java bytecode is really similar to this. Like I have some specially crafted instructions for making operations, like the one number is a constant. Then I just push it and blah, blah, the same operation. And from all these operations, I get the same result that I was talking before. The problem, or not a problem, depends on your point of view, is that we're talking about IAD. This is not an Apple gear. The main point is that we're talking about integer addition. Integer addition, which basically means that we're talking about a virtual machine that's statically typed and very tight typed. The point is that this sum is an integer. At least on Java, if you see it like this, without any clever tricks, it will be an integer. But when we are talking about Ruby, things change a lot, because 1 is not an integer in Ruby. In Ruby, we are talking about objects. Everything in Ruby is objects. OK, this is a lie. But for now, let's go on and assume that everything is an object. Ruby tries to force the yo-yo-o object-oriented paradigm a little bit further, promoting objects where it can. So this operation that we do on the top is almost the same like as calling a plus method. Which gets much better because when you are working with objects in Ruby, you get the concept of sending messages between objects a little bit further, because you can rewrite the same sentence like this. Instead of me calling a plus, I can send a message plus with some arguments to an object. So this send method clearly states, OK, we're sending messages, not giving orders. It's a good thing in general. But if we want to write this on Java, things get a little complicated. This will be the perfect implementation for a plus method. Anyone disagree? Yeah, this will be perfect. It's very simple. I have an object, and I want to add another object. The problem is that this isn't allowed in Java. You start to wonder. It's a very simple thing, like operator overloading, and I can have it. The point is that Java language, we love it, but the language is really limited. We are seeing from time to time that people were pushing the language forward, making amazing things, like the Lambda.j project from Mario that hates Ruby. There's tons of people that are using bytecode weaving to give more features to the language. But the language is limited, and that's OK. The point of the language being limited, being an OK thing, is because Java is much more like an assembly language for people doing serious stuff. Like you probably won't want to use plastic to build a foundation of a house, unless you live in Japan and you have tons of earthquakes, but that's another history. See, if we want to write this in Java, we are forced to adhere of the conventions of the language. So I really need to find a funny object. And talking about objects, I have jRuby object. This is an interface that every object in Ruby will implement, like it or not. Everything is an object. Consequently, I really need to provide the types, because the Java language really requires all the types, even the JVM, during compilation at least. We have some ways to circumvent this. And when we talk about the Java virtual machine, the most important thing that you can find is that everything is all about method invocation, and function invocation, and invocation, and invocation, and invocation. OK, this is boring. But why we need to bother about this? What I'm doing here, I'm essentially making a call, a simple call, method call. This is invocation. Here I'm making a virtual invocation. And where do the bytecode fits in? When I want to do this operation on bytecode, I just loaded my object. Look, that for me to be able to make the call of the operation plus, I really need to make a checked cast and verify that this method really has the method that I want to call. So I need to do all this stuff just to call a plus. In summary, I have 4 kinds of invocation on the virtual machine. The invoke static for static methods, invoke virtual, blah, invoke special for super constructor and new object creation, invoke interface for some level of dynamic dispatch. But let's go back to a Ruby code. These innocent Ruby codes don't have anything complicated. But this method, as you have seen, this honk method, it will become a dynamic method object. So in Ruby, you will have every method becomes an object. So things can get a little bit hairy when you think about performance. Because if I have a class with like 200 methods, you probably will have a very fat object. At least the class object will be very fat. And as you probably guessed, you will store these dynamic methods inside a map, inside the class. There is nothing new here. The main problem with this approach is that because when I want to call these methods, there's tons of things that are just happening under the hood that makes things really slow. And before anyone wants me think that I'm defending Ruby, no, Ruby is a really slow language. By definition, it's slow because it does tons and tons and tons of things that you don't need to worry in other languages like Java. So by definition, the language is slow. What's happening here? It's very simple steps. I first get the object. do a hash lookup, context lookup, because I have some objects in the environment that I need for making my operations. Then I do the actual invocation and finally a profit. Like, if you compare this with the normal Java invocation, it will be like 4 steps instead of 1. When you think in a system like a web application having thousands of requests per minute, that's a ton of overhead that we just can't afford. So what about if I could teach and tell to the JVM how to reach this dynamic method without making the lookup? Here the possibilities start to build up. Because at the same time, what if I was able to give the JVM more information about what it can do? Well, who is calling this method? How many times it has been called? The fact is that people thought about it, and the team from OpenJDK started to build the multi-language virtual machine, the Da Vinci project, that for a long, long, long time ago, they started to sketch something like, we want to have something dynamic on the JVM, new possibilities for my code. So they're born Invoke Dynamic from this project. This simple instruction and their friends. When we talk about the Invoke Dynamic friends, that because Invoke Dynamic is a bytecode instruction, but on the day-to-day, you need more than just the bytecode instruction for making anything useful. So we need to think a little better about what we can do with Invoke Dynamic. The principle of working, the principle of Invoke Dynamic function is like this. I emit an instruction like I want to call blah. Then I emit Invoke Dynamic bytecode. It goes to the bootstrap method or telephonist. She will try to find some method handles that satisfy this request. It will be bound on the target method there, and then the invocation happens. On the second time, when I'm doing this, OK, this is complicated. What happens? On the second time, the bytecode invocation that you have on the top, Invoke Dynamic, just go directly to the target method. So it's like, first time I just set up the negotiation, handshake, carrier detect, it's connected, and then go straight. So we have tons of performance improvements just to see very easily. We're talking about method handles, bootstrap method. Really, there's something wrong here, because supposedly Invoke Dynamic it was meant to make our lives as language designers much more easier. So what all this shit? Well, getting back to Invoke Dynamic on the basics of the basics of the basics. First, I have the method handles, which in the end, anyone knows what this means? Please. Please. Pointer function, or pointer to a function. This is basically what a method handle is. It's a pointer to a method. And you can even go further, and if you have static functions, you can just use method handles to point to these static functions and have a pointer to a function. Because when the JIT compiler starts to optimize stuff, in the end, it will become a true pointer. So you have the potential to have very fine level optimizations without making tons of complicated code. So this is the ugliest thing I could get to you. Basically, the API is a little verbose. As Java is verbose, we cannot avoid it. We can improve it a little bit. But essentially, I have this method type, method that is static. I just imported it for the sake of it. If I define the signature that my method will have with their respective types. So this method returns void, nothing. It's a void method. Receives an object and a string. It's an ADT2 method. Anyone doesn't know what ADT means? Please. if you don't understand something that I said, please just raise your hand. I will be more than happy to explain to you. Essentially, methods with 82 two arguments, methods with 81, 80, and go and there ahead. After I defined what type of method that I want to target, I will just make the lookup, find this method. In this case, I'm searching for a method named lol inside the RT class. And it's a static method because I'm using finding static. And then I just invoke this method with arguments. Because it's a static method, I just need to pass the arguments, and it will be happy. Here, I'm making something new. I'm just putting one argument in the method handle, insert argument. It's creating for me a new method handle. So the first thing that we can focus here, the method handle API has a very good upside. Everything is immutable. For us that are making concurrent applications, this really helps a lot on avoiding concurrency problems because, you know, concurrency is hard. It's better go shopping. The idea is that when I did this method handle will have the arguments, this one long. And now I just can ask for the same function, just passing the ones that we are missing. I'm essentially implementing currying on a Java level without any big problems. It's really, really simple. Another case that I have here, I am invoking this method with two arguments, everything normal. But what's happening under the hood? Because technically, this invoke with arguments function will need to have some, how can I say? How can I pass a long and a string? Here, there is no autoboxing happening. That's the whole point. You would think that is happening, but no. I'm passing the primitive here because this is a new thing on the Java 7. That's polymorphic signatures. You can mark during the bytecode generation a signature to be polymorphic, so it discards all the types. It's like a catch-all, and the compiler is happy, and we can pass garbage to it. That's the whole point. Another thing that I had on method handles, it's a structure for making calls, conditional calls, using just this API, this ugly API. The main idea is that I can make if conditions, like branch conditions, just using method handles. And this starts to get very close to functional programming that you had on like folds and fold left, fold right, and all that stuff. Because all the method handles are really inspired by these APIs. So, these APIs was inspired by all this functional stuff. So I can make combiners, essentially. And for this example, I have this very simple API, one test with the same signature that I can process and make some condition like, I want this code, if this object has a state that interests me, it will go to the do it. Or in the counter case, it will go to the or else. So essentially, I can construct a structure that is a guard with test that the method handles API provides for me for free. And I can use this for invalidation purposes, like as long as I know this class, please go straight. When there's a new type that I don't know, make all this low process, then go straight. So usually, when you are using this, you only pay for the first invocation. From now on, everything just happens magically and fast. Essentially, we are talking about bytecode, and we need to go back to bytecode. This is a standard invocation, probably most of you know. I just do invoke virtual, passing this information, the method name, the signature with the types. When I go to invoke dynamic, things change a little bit. Because right now, I'm just making an invoke dynamic instruction. I pass garbage, any string that I want. It's a constant. And on the sequence, I pass the signature that I want to use. when we are talking about static invocation, like invoke virtual or invoke interface, I need to specify the types. So I will say, OK, I want to invoke a method with a string and a long. But in this case, for practical purposes, you will just pass object. I want to have I'm calling a method with 3 objects that returns another object, and I don't care about the types. It's garbage, at least right now. So I will have this guy. Our signature looks like this. It's a string. Our bootstrap method, the telephonist, is something like this that returns a Callsite. There is another weird thing. Callsite essentially is where the magic happens. When you are invoking like car.honk, invoking this method, where this method is being bound, like I was calling the method, where this is happening is effectively the call site, the place where the invocation happens. So I can configure and prepare all my invocation and teach the JVM, OK, when you receive a magic dynamic invocation, you should go to there. And I'm doing this right now. I'm just look up the magic using the method Hendo API. Once I have a pointer to a method that I want to call, I just create a constant call site. This essentially will be responsible for me to just call, and everything will happen automatically and magically. And let's see. This is the best way to get this working. For now, I have a very, let's forget this for a minute. I'm just generating a class at one time because we don't have support for Invoke Dynamic on the Java language per se. I really need to generate code that makes the Invoke Dynamic calls so I can capture these calls later and make it work. So, sorry, I'm generating this class using an API called JavaScript. We will talk about later. So I'm making the most simple test that I could do. I will just make this method, make the invoke call on a simple method that just calls the invoke dynamic instruction. Let's go and hope that the demo gods help us. OK, we have a breakpoint on this first invocation. Now the magic will start to happen properly. Just to show you, I have my bootstrap method here. I have a very simple call, checking the name and blah, blah, blah. I will try to look up a method, named HelloBaba, inside this class. I'm making some currying here, nothing complicated per se. So let's go. As soon as I made the invoke dynamic call, it just goes to the bootstrap method, as I have said before. It makes the setup, compares the strings, are the same, OK. So I create a new method handle. I don't know if you can see here, but essentially it's Java lang invoke direct method handle pointing to that method that I want to call. After I make this, I just return a constant call site. In this case, I don't want this to change ever. Once I have set up my invocation path, I just want the JVM to do its work. OK, I made the call. If you go to the log, there's a call from Invoke Dynamic, blah, blah, blah. And now it's time to make the second call. It never reached the bootstrap method. Essentially, I just taught the JVM how to make a direct invocation. So you can imagine with our Ruby codes that has a map with tons of dynamic methods and all that stuff happening under the hood, I just tell the JVM, OK, when you have this method and this call, you do like this. And the JVM takes care of the rest. Why is this so important? Because essentially, I'm just skipping a ton of code. Because honestly, OK, this is not that simple, but at the same time, it's not that bad. If you get like 12 hours studying it, you probably will go hello world and much more than a hello world done. the main point is this starts to make a little more sense right now. I make the Invoke Dynamic call. My bootstrap method sets up the connection with method handles. And after that, the caller starts to talk with the Kali, and everything just happens. We're teaching effectively how the JVM should work. We are teaching how to link stuff. The bootstrap method usually is called linker for obvious reasons, because we are doing late binding and dynamic linking. And the truth is that the JVM is amazing. There's a very beautiful piece of code, has tons of research in it. And the best thing that we can do for the JVM is let it do its dirt job for us. I don't want to, someday maybe, I would like to work on OpenJDK, but right now it's much more far than my knowledge. So why should I care? Let the JVM do the job for me. So what about jRuby? We are talking about Invoke Dynamic in general, especially thinking on jRuby, but that's what's the result of Invoke Dynamic on jRuby. As you can see, we have 3 bars for several benchmarks, some artificial ones, some not that artificial, that they really had some true impact. As you can see, the rightmost column is the version with JDK7 with Invoke Dynamic enabled. There are some cases that the time fall like to less than half. And on micro benchmarks, we have found improvements of like 20-fold or 30-fold. That, of course, we won't put these kinds of benchmark here because, you know, benchmarks are lies. So we just use it for having an idea of what we want to achieve. So the truth is that things are looking really, really good at the performance side. And jRuby uses the Invoke Dynamic for several things, like constant handling. Can anyone please tell me what is a constant is? Constant. Yeah, technically it doesn't change. The problem is that Ruby constants change. You can reassign it anytime you want. So this amazing thing means that it's a pain in the ass to optimize it, because essentially I need to treat it like a mutable variable. So what we can do on jRuby, we are doing something with the guard with test. We use some new functionality on Java 7 named switch points, which essentially is like a global fuse for the JVM. When a constant changes, we just blow the fuse and let everything relink again. So usually constants are just assigned at the beginning of your application. So you just boot up your Rails application, big and fat. It goes, set all the constants, and that's OK. It probably won't change. And if it doesn't change, you get the same performance as public static final fields. It's really, really, really fast. In our micro benchmarks, there's sometimes that accessing a Ruby getter was a little marginally faster than accessing a Java getter. This has really big potential. As I said, if you are accessing instance variables and getters and setters, jRuby uses it too, because once you find where your variable is, you can access it directly. We are using it for FFI, fast forwarding invocation. Like I need to access a C library. When we are using Java, usually we are left to resort to GNI or GNA. And they are really nice APIs, do the job, but it's hard to program. With Invoke Dynamic, we make the binding to the native libraries using Invoke Dynamic and have tons of code, less code, and at the same time, I get very good performance. I haven't did any consistent benchmark because we are dealing with C extensions and there's tons of problems with synchronizations and blah, blah, blah. So I I didn't got any real number. The point is that it's faster. OK, I just can't say more. Basic math. Also, we have a problem with Ruby because the integer sum overflows. Like if I sum two very big numbers, they became a big decimal automatically. This is a good and a bad thing. Good thing because the user don't have a very bad surprise. But at the same time, for us, we are implementing, like I was storing the value on a long field, and then out of the blue, I need to change my storage and everything. So we can optimize tons of things using Invoke Dynamic for this. And the main and golden points that probably Mario will love. Who cares about this? Who cares about Ruby? Then it fails. I hate Ruby. If you hate Ruby, like this guy, you probably will try to find some way to bash Ruby because Ruby is slow. Ruby has several problems. The point is that we have possible uses that arose from the needs of an ugly and slow language. And this is really our $1 million check, because we can use faster than reflection invoking using method handles. Essentially, when you are using reflection, like the AES server, when it needs to do invocations, probably needs to use reflection. Any framework probably will use to need it. We need to use it. I can have faster invocation. Why? Because when I do my normal invocations via reflection, all the security checks are done every time. When I have method handles, they are immutable. So the security check is just done during the method handle creation. After that is that normal direct invocation with almost the same performance that you had before. So it's truly win-win situation. We can do and now that we have more power on the bytecode side, we can make finite state machines with bytecode generation. We can use this for example, for making a parser that emits parser generator that generates bytecode highly tailored for optimization. So I can enjoy the JIT compiler in optimizing my parser, optimizing my state machine. This has tons of potential too. Gtable expression language. So you have a mundane web application. If it uses Invoke Dynamic under the hood, the JVM will start to just see what it wasn't able to see before. See the calls, where they're happening, and how it can inline stuff. So essentially, I had much more information to give, like AOP, interceptors, and that kind of stuff. It can be inlined. So, OK, I don't know how it's the reality of the market on the US, but at least in Brazil, AGBs are not seen with good eyes. So do you have any idea of having an AGB that inlines right down to the bare metal, essentially emitting like ASM from your CPU? So some performance problems can just fade away. And of course, I hate to forget the expression, but when you have the icing on the cake is that the Java 8 lambdas are being implemented using Invoke Dynamic. So the JDK team are eating their own dog food. So all the performance improvements that we'll see, in other words, Invoke Dynamic will be fast because they need it. So if the same guys that are using it the same guys that do it are using it, we can expect more performance coming. So just to close, we really love Java. It's a really nice language. It has a solid set of features. It's easy for newcomers. People have some safety nets for the average Joe programmer that's starting his career. But at the same time, we have tons of power because we love even more the JVM. It has a potential to change the world just by allowing you use the best tool for the best job. Or in other words, Java is not the only answer. It's probably the most possible answer that you can have. But you have more options, and that's awesome. And to finish, the main rule of thumb, when we are dealing with language implementation and big systems and frameworks, the best code optimization we can do, don't. When you start using Invoke Dynamic, tons of things that you were supposed to do, like, OK, I have lots of invocation around my code. May I inline it or just do by myself, put everything on the same method to make it faster? No. I just make my code beautiful and let the JVM do the work for me. Please, don't. So that's it, pessoal. Pessoal, people, thank you. Any questions? Curiosity? Random trivia? No?
When is Invoke Dynamic supposed to be readily available?
It's available already. There's since the Oracle released the JDK 7 and OpenJDK project was available, it's available already. There is one catch. It's usable only after the JDK 7 update 4. Before it, you have several serious performance issues because they were more committed to the release date than of the QA. Yeah, that's true. Even the people from the Lucini project got really angry because they found a bug like 1 week before the release, serious bug, and they just pushed the release. So it's really available. It's pretty stable right now. There's people using it on production. That's the main point. Even Invoke Dynamic stuff, like we have some reports from users running jRuby on 7. So you can expect some level of stability. And things just tend to go better. And that's it. OK, thank you, guys.